Today we're going to talk about special pairs of angles, particularly those ones we talked about in our theorem class yesterday, but we weren't 100% sure what they were when we're looking through that packet. So let's clarify some things about angles today. All right, the very first special pair of angles we're going to talk about are called complementary angles. Complementary angles are angles whose measures add up to 90 degrees. So when I add two angles together and they equal 90 degrees, they are called complementary. Each angle is called a complement of the other one. So let's look at two possibilities. So that first possibility is that two complementary angles can be adjacent. But they don't necessarily have to be adjacent. They just have to add up to 90 degrees. So these would be a non-adjacent form of complementary angles, as long as in both cases the measure of angle 1 plus the measure of angle 2 equals 90 degrees. It doesn't matter if they're put together, it doesn't matter if they're a mile apart. As long as when you add them together they equal 90 degrees, they are complementary angles. Once again, I might say angle 1 is a complement, that was that word right there, of angle 2. All right, the next key special pair of triangles are called supplementary angles. Supplementary angles are a lot like complementary angles, except this time they're going to add up to 180 degrees. Each angle is called the supplement of the other. So if we look down here, we have one that's 50 degrees and one that is 130. When added together, they equal 180 degrees. So that means A and B are supplementary angles. I'm going to go ahead and write that down actually. So we have angle A equals 50, angle B equals 130 degrees. When added together they do equal 180 degrees. Alright, which means they are supplementary. Alright, next one says angle DEG is a supplement of GEF. We know that because it's probably one of the hardest things to wrap our heads around sometimes. Anytime I draw a straight line, we have to know that it is 180 degrees. So a straight line is 180 degrees. So that purple line right there is 180 degrees. So when I take one angle and I add another angle to it and they make a straight line, it is 180 degrees. So those two are supplements of each other. The big thing is if I say complement, think 90. If I say supplement, think 180. Complement 90, supplement 180. I kind of think of like a nice supple apple. A supple apple is like a big juicy apple. So if we're talking about supplementary, it's the bigger of the two. It is 180. I guess last year we came up with complementary. It's a complement to be lower or whatever. But however you want to keep track of it, complement is 90, supplement is 180. All right, find the complement and the supplement. That's actually spelled wrong, but this should be complement and supplement to each angle. All right, measure of angle A is 10. So we're going to do our complement and then we're going to do our supplement. Well, our complement is just going to be 80 degrees because 80 plus 10 equals 90. In other words, all we had to do was take that 90 degrees and subtract 10 degrees from it. All right, the supplement is the one that makes it add up to 180. In this case, it'd be 170 degrees. And that's because 180 degrees minus that 10 degrees is 170. 170 plus 10 equals 180, supplement. 10 plus 80 is 90, complement. Same thing here. So when I'm looking for my complement, I'm looking for an angle that added to A equals 90 degrees. In this case, it's 15 degrees. 15 plus 75 equals 90. The supplement, on the other hand, needs to add up to 180. In this case, it's going to be 105 degrees. 105 plus 75 equals 180. Our last one's a little weird. We don't have an actual value. We have y. So what I'm going to do is I'm going to go back to what I wrote on the very first square. I said, Well, a complement is 90 minus 10. A supplement is 180 minus 10. So since we don't have a number, all we can say is, well, the complement is going to be, if I have 90 degrees and I subtract y away from it, that is my complement. My supplement is going to be, if I have 180 degrees and I subtract y away from it, I'm left with my complement. That'll work for any y value. In fact, if we look at this middle part, if I would do 180 minus 75, that was the angle that was given to me, I'm going to end up with my 15 degrees. I'm sorry, I did that for the sub. Let's go back. I meant I would do 90 degrees minus 75 degrees. That would be my 75 degrees. That would equal my 15 degrees. The 180 would work with the supplement, which would give me that 105. So the same thing works if it's y, or if I give you x is the value. That's kind of the definition of complement and supplement. All right, the next thing we're going to talk about is something called a linear pair. A linear pair are two angles that are adjacent, so that means they're joined at a vertex and share a side. So they are adjacent. If I could spell that, we'd be much better off. And they form a supplementary angle. Which just means that it's going to equal 180 degrees. So there are two angles that put together, well, I have the 180 down there. When we put two angles together, if they equal 180 degrees, they're called a linear pair. So here's an example of that. So if I have a straight line, and I divide that up into two angles, let's call them angle 1 and 2. Since angle 1 plus angle 2 are adjacent, because they do share a vertex and they share a side, and they form a 180 degree angle. Remember, I said what we're looking for there is we're looking to make sure that it is a straight line, which I went over a little bit, but we can see that's a straight line. So when we add them together, they make a straight line. They are adjacent. That means they are a linear pair. So linear pairs always add to 180 degrees. Just like supplementary, I want you to think linear pairs, 180. Supplementary, 180. Complement, 90. All right, let's continue on. We're going to talk about something called vertical angles. Now, I think vertical, I think up and down. And we're kind of thinking that way. Vertical angles are the angles that are across from each other. They are across from each other. When two lines intersect. So when I'm looking at two lines intersecting, so that's kind of the big thing, we have to look for two lines intersecting. So two lines need to intersect, and then we have some vertical pairs, or vertical angles, I should say. Well, the first set of vertical angles I'm looking at are angles that are straight across. So that would be C and D. So angle C and angle D are vertical angles. A and B are also vertical angles. They're straight across from each other. You can draw a straight line and it would connect them. So A and B are also vertical angles. So A and angle B are vertical angles. All right, cool. I do want to show an example of something that's not vertical angles. It is something I see a lot on like tests that people think they're vertical angles, so we're going to put a little not. This is not going to be vertical angles. Not a vertical angle is going to look like this. Note we have a line, we have another line, and we have a third line. To be vertical angles, it can only take two lines intersecting. So 1 and 2 here would be not vertical angles. Not vertical angles. It must be just two lines crossing each other. All right, that's a vertical angle. We talked about postulates, we talked about definitions yesterday, and we said a postulate and a definition were statements that don't need to be proved. They're just given to you and you can use them. A theorem, on the other hand, is a statement that needs to be proved. So a theorem is needing of proof. Let's highlight that. So we said yesterday a postulate. A postulate requires no proof. We just accept it as being true. A theorem is a little stronger because we will prove it. We will either prove it together or I'll show you a proof that proves that it is true. So the very first theorem that we're going to talk about is something called the vertical angles theorem. The vertical angles theorem says vertical angles are congruent. A good idea is to locate this in your packet, highlight it, or put a star by it because we actually use it a ton. In fact, we'll probably use it so much that you don't need to look it up, but it's a very important one. So vertical angle theorem says vertical angles are congruent. And in order for them to be congruent, they must be the same size. So if I say two angles are vertical angles and one is 45, we know the other one is 45 as well. Now we're going to go ahead and do a proof. This is probably the biggest proof we've done so far. So we are given angle 1 and angle 2 are vertical angles. And we also provided a drawing up here. So we got these two things are vertical angles. Boom, boom, boom. All right. Well, that's my given. Now, normally if I was proving this, so notice how I said angle 1 and angle 2 are vertical angles. Normally, if I tell you something like that, if I tell you something's an angle bisector, if something is a midpoint, our first step is usually to look in our definitions page. However, if we look at our definition page, we don't even have a definition of vertical angles on there. So this is going to be one of the weird cases. We're going to do something slightly different. And we're going to use something from actually this lesson. And what we're looking at is the fact that measure of angle 1 plus measure of angle 3 equals 180. And measure of angle 2 plus measure of angle 3 also equals 180. There's really two reasons for this, all kind of mixed into one. So what I want us to look for, what we're going to look at is actually the linear pair definition. If we look at the linear pair definition, it says two angles that are adjacent and form a line. Now, in your notes, you can actually underneath that line put 180 degrees. That is two angles that form a 180 degree angle. So, look back at 2. It says measure of angle 1 plus measure of angle 3 equals 180. And measure of angle 2 plus measure of angle 3 equal 180. Note 1 plus 3 create that straight line. 3 plus 2 also equal that straight line. So by the definition of linear pairs, we can say that those two things equal 180 degrees. So we're going to use our definition of linear pairs. There's one more that I would accept. I would accept if you kind of turn the pages, you're going to eventually find something called the angle addition postulate that says two angles can be added together. I would allow that one, but the definition of linear pairs is a little stronger there. All right, so we have measure of angle 1 plus measure of angle 3 equals 180. Measure of angle 2 plus measure of angle 3 equals 180. And look at our next step. The question is always what happened between step 2 and step 3. So what's actually happening here is I'm taking that measure of angle 2 plus measure of angle 3 and I am substituting it in place of that 180. Now, in order for this to work, I said that key word. I used the word substitution. I'm replacing 180 with something else. Substitution is going to be one of those really big ones we use a lot. And that's going to be on the very front page of your theorem, postulate, definitions page. It's the first one after your properties of equality. It is your substitution property. It says if x plus a equals c and a equals b, you can replace a and b. So our step 3 is going to be substitution. And you could just put substitution. You don't have to put substitution property. It is the only thing with substitution in it. All right, our next one, step 4 says we have measure of angle 1 equals measure of angle 2. So let's look what happened there. Somehow we got rid of these two things. So we just got to ask ourselves, how did I get rid of measure of angle 3? Well, I must have subtracted it away on both sides. Well, if I'm subtracting something on both sides, we are using the subtraction property of equality. Now, the good thing about theorems are, as soon as we prove it, you can use it without proving it again. So we now can use our vertical angle theorem to use in other proofs. All right, let's quickly go to example 2. We're just using this idea behind our vertical angles being congruent. So let's look here. We have two lines crossing. Let's highlight that. We have one line, two lines. That means we have vertical angles. I'm going to circle my vertical angles. We have this pair of vertical angles. And we also have this pair of vertical angles. Well, vertical angles are congruent. So that allows me to say they're equal to each other. So I can then say that 7y minus 12 equals 6y plus 8. And I can also say that 4x equals 6x minus 26. Now I can solve for y and x. So on the left-hand side one, I would subtract 6y minus 6y. What lets us do that? Well, that's our subtraction property of equality. We're not doing a proof, but it's always good to keep that in mind. All right, so we have y minus 12 is going to go ahead and equal 8. Then we're going to add 12 to both sides. Once again, this would be our addition property of equality. And we'd be left with y equals 20. All right, now let's solve for x. X, there's a bunch of different ways we can actually solve this. What I'm actually going to do is I'm going to go ahead and subtract 6x from both sides. So let's subtract 6x from both sides. Or however you want to solve it. If you know how, just do your own method. All right, we have negative 2x equals a negative 26. Then I'm going to use the division property of equality to divide both sides by negative 2. And we are left with a positive x equals 13. I now solve for my x, I solve for my y, as long as I know what vertical angles are. All right, that's it for the lesson. I do want to point out that number 23 is a proof, probably our first big 4-step proof. Give it a shot. Give it your best effort at what's happening there, and then we'll just talk about it tomorrow. All right, have a good evening.